System design basics. How to architect scalable applications. Alright, quick question. Why can Netflix stream millions of videos at the same time without crashing, but your side project falls apart after a few hundred users? What makes systems like Amazon, Uber, and Twitter so scalable while others struggle? The answer is system design. It's the secret sauce behind applications that handle millions of users without breaking a sweat. And today, I'm going to show you exactly how to design scalable applications, even if you're new to system architecture. By the end of this video, you'll understand what system design actually means without the jargon, how to design apps that scale efficiently, real-world examples from companies like Netflix and Twitter. Let's get into it. Alright, first things first. What exactly is system design? System design is the process of planning how an application works behind the scenes, from handling millions of users to ensuring data doesn't get lost. Think of building a house. You don't just start throwing bricks together. You need a blueprint. You need to decide how many rooms, how strong should the foundation be. Will it handle an earthquake? In software, system design answers similar questions. How do we handle millions of users? How do we prevent crashes? How do we store and retrieve data efficiently? If you're a developer, learning system design helps you build apps that don't just work today, but to scale for the future. The 5 key components of a scalable systems. So, how do you actually design a system that scales? There are 5 key components you need to think about. First, load balancing, keeping things fast under heavy traffic. Imagine a popular restaurant with only one cashier. If too many customers arrive, the line becomes a nightmare. The fix? More cashiers. A load balancer does the same thing. It distributes incoming requests across multiple servers, so no single one gets overloaded. For example, when millions of people press play on Netflix, their request doesn't go to one server. It gets routed to the fastest, least busy one, thanks to load balancers like Nginx or AWS Elastic Load Balancing. Second, caching, making the slow things fast. Ever notice how Google suggests results instantly as you type? It's not doing a fresh search every time, it's using caching. Caching is like a shortcut. Instead of recalculating data every time, it stores frequently used results for super fast retrieval. Take Instagram, for example. When you open the app, your feed isn't built from scratch. It's cached, so it loads instantly. Services like Redis and Memcached make this happen. Third, database scaling, handling massive amounts of data. A small app can run on a single database. But what happens when you have millions of users? At some point, your database will become the bottleneck. There are 2 ways to fix this. Vertical scaling. Get a bigger, more powerful server. Horizontal scaling. Split the database across multiple smaller servers, also known as sharding. Twitter started as a monolith, but as it grew, they sharded their database, splitting users into different servers so queries could be processed faster. This keeps Twitter fast, even with millions of tweets per second. Fourth, microservices, breaking the system into smaller pieces. Let's say your system gets huge. Instead of running one giant app, you break it into smaller independent services. That's microservices. Imagine a restaurant with one chef who does everything. Now imagine a team. One person does drinks, another makes desserts. More efficient, right? Microservices let companies scale individual services. If the payment system gets heavy traffic, scale it without affecting the rest. Deploy updates faster. Fix bugs in one service without redeploying the whole app. Uber started as a monolith, but now they have separate services for payments, ride matching, notifications, and more. This lets them handle millions of rides per day without breaking. Fifth, event-driven architecture, making apps responsive and efficient. Last but not least, how do you make sure parts of your system talk to each other efficiently? Event-driven architecture uses message queues like Kafka or RabbitMQ to handle real-time updates. For example, when you send a message on WhatsApp, it doesn't immediately hit the recipient. Instead, it goes through a message queue that ensures delivery, even if the user is offline. This makes messaging systems more reliable and scalable. Recap: how to design scalable applications. Alright, let's recap. To build the scalable systems, you need to think about load balancing, distribute traffic to prevent overload; caching, store frequently used data for the speed; database scaling, use sharding or replication for large datasets; microservices, break apps into smaller independent services; event-driven architecture, use message queues for real-time communication. These concepts power the world's biggest applications, and now you know how they work. What's next? Now that you understand the basics of system design, the next step is seeing how real companies implement them. Watch my next video, How Netflix Scales to Millions of Users Deep Dive. And if this video helped, don't forget to like, subscribe, and hit the bell for more system design breakdowns. Scalability is what separates small apps from billion-dollar platforms. Master these concepts, and you'll be ahead of 90% of developers.